All right, we are now solving quadratic inequalities. So your notes look like this, I hope. There's a spot for your name if you want to put your name in there. They look a little bit different. Um, here's what I want you to know from the very beginning, because I still do this in pre-cal and students still don't listen to me, okay? We, that means including me, we cannot solve quadratic inequalities algebraically, like we did in the warm-up. There is no rule that says, just flip the inequality when you multiply or divide by a negative like there is for linear inequalities. So how do we solve them? We must solve them graphically. We must solve them graphically. Okay? So here's a follow-up question. How do we solve quadratic inequalities? Graphically. Very good. True or false? A quadratic inequality can be solved algebraically. False. Okay, very good. Got it? You're still going to be trying to solve it algebraically. I'm going to be like, why are you doing that? Why are you doing that? It doesn't work. Okay, let's take a look at number 1A. Our function is x squared minus 8x plus 12. What do we know about that function without even seeing the graph below? We know that it is a quadratic. It's x squared. It opens what? Up or down? It opens up. What's the y-intercept? 12, right? You plug in a 0 for x and you get 12. So the y-intercept is 12. Should be. Should be, but it's not. Is that what you're saying? It should be, but it's not. I got it. Now, I want to know for what values of x is x squared minus 8x plus 12 greater than 0. Okay? Here is the graph of x squared minus 8x plus 12. I want to know for what values of x it's greater than 0. Here's what we are actually asking. We want to know for what x values are the y values of the graph greater than, in this case, means above 0, which is the x-axis. That's how you want to interpret it. For what values of x are the y values of the graph greater than 0? Greater than 0 means above the x-axis. So, if it's all in reference to the x-axis, let's find the x-axis. The x-axis, oh, I see it. The x-axis is right here. Does everyone see where the graph is above the x-axis? That's a real easy thing to see, right? I spy the graph above the x-axis here and here. The question then is now, for what values of x does that happen? Well, it's going to come down to the x-intercepts, right? These are the values of x where it crosses the x-axis. The answer is going to always be one of two things. Either outside the x-intercepts or between the x-intercepts. It's either outside the x-intercepts or between the x-intercepts. And what's the answer here? Outside of the x-intercepts, okay? And because it's strictly greater than 0, I can put an open circle on this x-intercept and shade to the right, and an open circle around this x-intercept and shade to the left. Okay? I'm going to write this right here. The answer, every single time, will either be between the x-intercepts or outside the x-intercepts. Always between or outside of. So this one is definitely outside of. I can see that to the left of the left x-intercept, I have positive y values. That's what that means. And to the right of the other one, I have positive y values. Now, I just need to find out what those x values are. Can I get those from the graph? I think I just shaded right over the marks. What mark does that look like? It looks like x equals what? If you count by ones on the x-axis, that looks like it's x equals what? 2? Does that look like x equals 2? And then 3, 4, 5, this looks like x equals 6. Yeah, it looks like x equals 6. So, is there a way to actually verify that? Yes. How do we verify it? Let's find the roots or the x-intercept of f of x. We'll say x squared minus 8x plus 12 equals 0. Does that factor? We always try to factor when it's equal to 0. Does that factor? Factors of 12 that add up to 8, 6, and 2, and they have to both be negative, right? Now here's the number one most missed question on yesterday's quiz. I think it was the last one on the front page. It said to find the roots of the function. Well, you set it equal to 0, you factor it, and a lot of people went this. They went with the answer choice -6 and -2. Is that right? No. Okay, you see x minus 6, you think, oh, -6. You see x minus 2, you think, oh, -2. But that's not the answer, because what's happening is we're setting x minus 6 equal to 0, and we're setting x minus 2 equal to 0. So we get x equals +6, or x equals +2. Okay? So be careful. A lot of people who got it wrong, or most people that got it wrong, skip this step right here. This is the zero product property step, where you set each of them equal to 0. I don't care if you skip that step. In pre-cal, we skip that step. We just say, if x minus 6 is the factor, x equals 6 is the root. If x minus 2 is the factor, x equals 2 is the root. We skip that step of setting a means equal to 0. So if you skip it, just make sure that you're showing the number that has the opposite sign from what's visible. Okay, now those were the right two values over here. So now we just answer the question. So in set notation, it's going to be the set of all x such that x is strictly less than 2 or x is strictly greater than 6. It's outside the x-intercepts. What's that going to be in interval notation? Well, it's x epsilon, and we need a placeholder to the left of 2. What's our placeholder for the left of 2? How far to the left of 2 are we shading? All the way to -infinity, right? So it's -infinity up to 2, union 6 to infinity. Remember doing set and interval notation? Oops. There you go. There's the answer. We're solving quadratic inequalities, much like we already solved absolute value inequalities the same way, didn't we? So it's not a real stretch from the V graph to having a U graph. That pretty much is the same idea. Okay, we're just finding the x-intercepts a little bit differently now. All right, questions on that one? All right, letter B. Now we have x squared plus 4x minus 5. It's another parabola that opens up. Now I want to know, where is that graph less than or equal to 0? So let me go ahead and translate it. I want to know the x values where this graph, where the y values of this graph, less than or equal to. Less than is now what in relation to the x-axis? Above or below? Less than 0. Below. This is below, and the equal means or on the x-axis. So that's how we translate it when we read it like that. For what values of x is this parabola, or the y values of the parabola, below or on the x-axis? Well, do you see where it's below? I see it's below right there. My x-intercept looks like it's, let's go ahead and find the x-intercepts before I obliterate it. My x-intercepts appear to be at 1 and -1, 2, 3, 4, and maybe -5. So is it going to be between -5 and 1 or outside of -5 and 1? Outside, so like over here? For all these values of x, it's below? Oh, no, I see. For outside, it's above, right? Yeah, it's inside. It's between. It's everything between, okay? So it's going to be from here all the way to here. And because it's equal to, I can fill them in. So in other words, on that connected x interval, which is now the AND case, if you recall, everything between -5 and less than 1, it's going to be below. Let's just make sure that those are the right x-intercepts. Let's set f of x, x squared plus 4x minus 5. Let's set it equal to 0 and see if those in fact are the right x-intercepts. This factors into x and x. Factors of 5 that add up to 4 are 5 and 1. And what are the signs? Well, it has to be a +5 and a -1. So that means x equals what? If x plus 5 is the factor, what's the root that goes with it? Is it 5? It's negative 5. Good. And if x minus 1 is the factor, what's the root? Positive 1. It's the opposite sign. Okay? If you see x plus 5, minus 5 is the root. Because that's the value, when we say the root, that's the value that when you plug it in for x gives you 0. Negative 5 plus 5 is 0. Okay? Are those the two values we found over here? Yes. So now we answer the question. In set notation, remember, it's the set of all x such that, and we have to list it from least to greatest. So it's negative 5, x, and 1. This is your compound inequality. This is everything between. It's the and case. Everything over here outside was the or case. Remember the and case, we put either less thans or less than or equal to's, and these are both less than or equal to's. Okay? We studied that at length when we did absolute value inequalities. So hopefully the notation is easy for you now. Least to greatest, small number on the left, big number on the right, x is in the middle, and they're either less thans or in this case less than or equal to's. And in interval notation, it's x epsilon. We go from negative 5 to 1 on an interval, and what do we put around the two numbers? Brackets or parentheses? Beefy brackets, right? Beefy. Beefy. Beefy brackets. There you go. So far, so good, right? So good so far. All right, y'all do the next one on your own. On your mark, set, go. I'm going to do it quietly. Y'all do it quietly on your own. We'll compare answers. Ready, set, go. Thunder. Don't eat this part. Hey, Spider-Man. It depends if they're on or off duty. Are you talking like Clark Kent versus Peter Parker? Or? Oh. Oh. Like me now or like me when I was your age?
Now.
Oh, probably you because I don't fight much anymore. I'd let you win. I'd let you win. I wouldn't want to hurt you.
Yeah, you might.
I probably would have gone like I probably would have put you in the hospital. Yeah, no offense. I was a little wild back then. Just a little wild. But Superman and Spider-Man, Superman would beat Spider-Man.
Really?
Yeah. But they wouldn't, yeah, but I don't think they'd ever quarrel. Part of Superman's superpowers are diplomacy.
What does that mean?
It means he would placate the situation and avoid the fight altogether.
Why did he
He's
fight Batman?
Oh, because Batman's a jerk. Yeah. Batman's a spoiled brat. It was self-defense. All right. You got a parabola that opens downward. The parabola opens downward. I want to know where it's less than or equal to 0. That's below the x-axis. You can clearly see that's outside the x-intercepts, right? So it's to the left of -6 and to the right of 2. Now the graph appears to be at -6 and 2. I just verified it right here. If you ever have a negative leading coefficient and you want to factor it, factor the negative out first. That changes all the signs. It's very difficult to factor when your leading coefficient is negative. So you factor out the negative, and then the inside factors as x plus 6, x minus 2, and here we go. Without setting them equal to 0, if x plus 6 is the factor, what's the corresponding root? -6. And if x minus 2 is the factor, the corresponding root is +2. So what appears to be a -6 and a 2 on the graph are actually a -6 and a 2. So now we just have to write it in set notation and interval notation, and hopefully that's not the obstacle. Okay? Yeah, it's 10 minutes, you can go. Yeah. Okay? All right. Comments or questions on that? All right. Let's go ahead and find the solutions to this quadratic inequality. Now, this one, the graph is not given to us, is it? Okay. Now, I can quickly determine if it's going to be an and case or an or case before I even sketch the graph succinctly. More thunder. Does this parabola open up or down? It opens down like that. Draw yourself an x-axis. I want to know where it's less than 0. Is that above or below? Below, okay? It's going to be below over here and over here. Is that outside or between?
Outside.
That's outside of. So we already know it's going to be the outside or case. We already know it's the outside or case. All we need to do is to find the x-intercepts. And to find the x-intercepts, I need to factor it. So let's set -x squared plus 8x minus 12. Let's set it equal to 0. I'm going to set it equal to 0 so I can find the roots. Just like I mentioned, we have a negative leading coefficient. Do we like that? No, let's factor it out. That gives us x squared minus 8x plus 12, and that equals 0. And now I can double bubble what's left with the negative still hanging around out front. Factors of 12 that add up to -8. X minus 6, x minus 2. Is that everyone okay with that? That gives you a positive 12 and a -8. And now let's list the roots. X equals what? If x minus 6 is the factor, what's the root? Positive 6. And if x minus 2 is the factor, what's the root? Positive 2. Yeah, so now I can actually sketch it. Here's positive 2. Here's -6. It opens down so it goes up and it comes back down. You don't really need to be super accurate. You just need to know the x-intercepts, okay? Now I want to know where it's less than 0. That's all this right here. So it's going to be strictly to the left of -6 because it's the strict less than, and strictly to the right of 2. Oh, yeah, what did I do? I did -6, yeah. Sorry, I had the right roots. I drew it wrong. Thank you. It's positive 2. Let's do it again. Thank you. Positive 2 and positive 6. So he's a tall, skinny little fella. There you go. Yeah. Well, those are the x-intercepts. Now for the inequality, those are going to be open circles. So now I'm going to put an open circle around it and sketch this way, and an open circle around it and sketch that way. I just put solid dots to show the x-intercepts. Now I put open circles and sketch outside of. Thank you. Thank you. Good catch, guys. Y'all's fault, my mistake. All right. Teamwork. Set notation. The set of all x such that x is strictly less than 2 or x is strictly greater than 6, sorry. And interval notation would be x epsilon, -infinity up to 2, parenthesis, union 6 to infinity. Ta-da! Sketching the actual graph almost messed me up there. I already knew that it opened down. I already knew it was outside the x-intercepts. I already had the x-intercepts. For some reason, I made it -6. All right, we're solving all of these how? Algebraically? No, we're solving them graphically. We're doing a little bit of algebra to find x-intercepts. That's the algebra. We have to find the x-intercepts. But then it's either going to be between them or outside of them, depending on whether it opens up or down, and depending on what the inequality is. Okay, we got one last one before we got some review problems. Okay, what do I know about this one? It's a parabola that opens what, up or down? It opens up, so if I draw a parabola that opens up, give yourself an x-axis. I want to know where it's less than or equal to 0. That's below, isn't it? Is this one going to be the and case or the or case? Between or outside of? This is the between case, right? This is the between case. So this is the and case. The between. Oh, because this is what we talked about. Anything that's this or this is the or case. It's either here or here. It's not in both, right? So that's when it's outside. That's the outside case. That's always the here or here. But in this case, any number like you pick, let's pick a number, like let's say this is -5, and let's say this is 5. You pick a 4 right there. 4 is greater than 4 is greater than -5, and it's less than 5 at the same time. Okay, it can be both greater than -5 and less than 5 at the same time. It's in between them, okay? That's what the and case means. So just like with quadratic inequalities, we called this back in the day, we called this disjoint. We called this the disjunction. You remember the disjunction? That's the disjunction, and this is what we called the conjunction. Those ideas are still going to be used even when we talk about other functions, okay? It doesn't have to just be absolute values. Anything that goes away is a disjunction and is an or case. Anything that's connected and is between is an and case and it's a conjunction. So we know this is the conjunction, right? We just need the x-intercept. So let's come over here and say 2x squared minus 4x minus 16 equals 0. What's the first rule of factoring? I'm going to pull the 2 out.
Teachers, pardon the interruption, just one quick announcement. If you have any seniors who signed up for the college fair, you can release those students at this time to report to the gym. Again, that's any seniors who signed up for the college fair. They can report to the gym at this time. Thank you.
So we didn't have a negative leading coefficient. We didn't factor out the negative to make it easy to factor, but they were all even numbers. So I pulled out the 2, and that made the x squared coefficient a 1, which is nice. So now I can double bubble it. The 2 is still out front. Factors of -8 that add up to -2. Factors of -8 that add up to -2. 4 and 2, and which one's negative? The 4. Very good. So now we can just say the roots are, if x minus 4 is the factor, what's the corresponding root? Positive 4. And if x plus 2 is the factor, what's the corresponding root? -2. Very good. All right, so now I'll sketch this. It's 4 and -2, and it opens up. So it looks something like this. And I want to know where it's less than 0. That means I want to know where it's below. So that's there and there. And again, it's less than or equal to. So solid dot now, solid dot, and I shade in between. So in between is the and case, right? Pick a number like 2. 2 is both greater than -2 and less than 4 at the same time, isn't it? It's both greater than -2 and less than 4 at the same time. That's why it's an and case. So here's our solution set. It's the set of all x such that -2 is less than or equal to x is less than or equal to 4. Least to greatest, and they're less than or equal to's. The interval notation would be x epsilon, -2 to 4 with beefy brackets. Now you're up, Mia, if you want to. Yeah. Boom, boom. All right, questions on that? All right, we just did 5 examples. 1, 2, 3, 4, 5 examples. They were all worked exactly the same way. Find the x-intercepts, know if it opens up or down, Look at the inequality. Are you looking to see if it's less than, below, or greater than, above? Is it strict inequality or is it an equal sign? And then just answer it. It's either going to be a disjunction, the or case outside of the x-intercepts, or the conjunction, everything between them, the and case, right? That's it. It's one of the two. That's it. It's not going to be something different than that. It's the disjunction or the conjunction. Conjunction, junction, what's your function? Hooking up nouns and phrases and clauses. All right, any other comments on here or questions? All right, let's go ahead and talk about this. This kind of goes over the last two quizzes where some of the work is still left to be desired, right? A, simplify. -7 times the square root of 60. The first thing I'm doing when I see a negative square root or square root of a negative number is, again, I'm saying it's the square root of the positive number, and I'm putting I on the outside. I'm putting I well on the outside. If I even think that your I is under the radical, I'm counting it wrong. Full credit wrong. No partial credit at all. Okay? And now 60 is not a perfect square. So I go off to the side, and I get the prime factorization of 60. It's 6 and 10. That's 3 and 2. This is 2 and 5. There's the prime factorization right there. I look for pairs of factors. Pairs of factors. There's a pair of a factor right there. So I can pull. I'm going to come over here. -7 is still there. But in terms of the 60, I can pull a 2 out front. And then what's left underneath there? The 3 and the 5 become a 15. And there's an I on the outside. And now all I got to do is combine the numbers in front, and I get -14 square root of 15 times I. And there's your answer. Or if you're a multiple choice question, your answer choice could be written like that. I don't like that nearly as much. I like the I on the back end as a variable, clearly outside the radical. Review. Comments, questions? Okay, this one, inch by inch, it's a cinch. Our goal is to expand it out. Let's just multiply it completely out. We're going to FOIL this one right here. 3 times 1 is 3. 3 times -6i is -18i. That looks good. Then I go -2 times -2i times 1 is -2i. And then I go -2i times -6i. Here's where you got to be careful. What's -2 times -6? +12. What's I times I? I squared. I'm going to leave it as I squared right there. That's +12I squared. Okay, good. Now I distribute a -2 and I get -8. And then I get +2I. Now I go through and I combine my numbers. I have a 3 and a -8. That's -5. I combine my i's. What happens to some of my i's? Well, these 2 i's and -2 i's, those cancel. And I'm left with -18i. And now, what do I do with the 12I squared? Since I squared is -1, +12I squared turns into what? -12. Yeah, -12. And now I have one last thing to do. I combine my numbers. -5 minus 12 is -17 minus 18i. That's in your A plus BI format. Your real part goes first, and the imaginary part with the I goes second. It's like I'm doing laundry over here. Washboard abs. All right. Everyone got that? Step by step, inch by inch, it's a cinch. All right, and then this one. How do I get the I out of the denominator? I bet 99% of the people are doing this right. I got to multiply by a clever form of 1. And I multiply by the conjugate of the denominator. What's the conjugate of 2 plus I? 2 minus I. Yeah, 2 minus I over 2 minus I. And now I just multiply straight across. So in the top, I have to distribute. That is 8I minus 4I squared. That is the numerator. In the denominator, I shall FOIL and get 4 minus 2I plus 2I minus I squared. So my first step is just to expand. Now I will go through, if I have like terms, I'll combine them. And if I have I squareds, I'll change the sign of that term. In the top, I have 8i. What does negative 4i squared become? Positive 4. I squared is negative 1. So negative 4i squared changes the sign, becomes positive 4. I squared is negative 1, remember. In the bottom, your two i's cancel. Those cancel. So you're left with 4 minus I squared. Well, what's another name for negative I squared? Positive what? Not I, positive 1. Remember, I squared is negative 1. Negative 1 times a negative 1 is a positive 1. All right, we still have some work to do. That's 8i plus 4 all over 5. And then the last thing we have to do, some people are still messing this up at the very, very end. We write that as 8. Ooh, that's not a good 8. 8 over 5i plus 4 over 5. Is that where we want to stop? Not quite. New column. Yum. We wanted an a plus bi format. So the last thing we have to do is just swap them. Yeah, 4/5 plus 8/5 times I. And there it is. Once again, inch by inch, it's a cinch. Inch by inch, it's a cinch. Piece of cake. All right, questions on that? All right, last two. Review. We got to review because everyone's still, you can use some practice on this stuff. Some people are still pretty weak on it. Solve by the square root or factoring. I'm gonna do the square root first, okay? Because people are still messing this up. If you solve by the square root method, you get the x squared by itself. So bring the 16 across, okay? So now we get x squared equals 16. Now all we have to do is take the square root of both sides. And when you take the square root, you have to bring into, on your own, you bring in what when you take the square root? Plus or minus, yeah. When you take the square root, you bring in plus or minus. And of course, what is the square root? Oh, stupid. What is the square root of 16? 4, yeah. So the answer is plus or minus 4. Not 2, 4, 4, 4, 4, 4, 4. We got it. Now, you could also solve this one by factoring. X squared minus 16 is a special product. It's a difference of two perfect what? Not circles, but squares. So it factors into the product of two whatchages? Conjugates, right? So it's the square root of 16, which is 4. So it's x plus 4 and x minus 4. And now you can rattle off the roots. Let's do it again without setting them each equal to 0. If x plus 4 is the factor, what's the corresponding root? Negative 4. And if x minus 4 is the factor, what's the corresponding root? Positive 4. Those two say the same thing, right? Plus or minus 4 versus negative 4 and 4. You can list them twice or plus or minus conjugate pair. So two different ways to solve this one. And the last one, everyone's favorite to hate. Solve by completing the square. This is the one, I think this was the last question on the quiz yesterday, and it was probably the most widely missed question. All right, so to complete the square, the way I teach you to complete the square is to do it all on the same side. So we already got the coefficient of x squared to be 1. That's good. So minus 2x plus something plus 6 equals 0. This is how I've done it every time, right? Half then square, half then square, half then square. What's half of negative 2? Nope. Negative 1. But what's negative 1 squared? Positive 1. And if that's a positive 1, what does the next blank have to be? A negative 1. Yeah. Now I group these three together. And that factors into a binomial squared. It's the square root of x squared in the front, the square root of 1 in the back, and the middle sign in the middle. So it's x minus 1 squared. And then what do we get here? What's negative 1 plus 6? That's 5. Now this is where people stopped. People were giving answers on the quiz yesterday as 1 comma 5. That's the vertex. I wasn't asking for the vertex. I want the solutions. So for the solutions now, we do the same thing that we did right here. We get the x squared by itself. So Red Rover, let 5 come on over, and we get x minus 1 squared equals negative 5. X minus 1 squared equals negative 5. Now, how do I unsquare something? Square root it. So I get x minus 1 on this side, and on this side I get plus or minus the square root of whatever number's over there. Again, I bring into the fray the plus or minus. I took the square root, so I have to bring the plus or minus in. Now, before I do anything else, I notice I have a negative under the radical. Yucky, yucky, gross, gross. So I'm going to bring the negative from under the radical out on the back and call it an I. And now, some people got this far on the quiz and then didn't know what to do. All we're trying to do is solve for x. Right now, I have x minus 1. How do I do subtracting 1? Add 1. I just add 1 to both sides, or bring the negative 1 across to the right-hand side and put it in the front. So you get x equals 1 plus or minus the square root of 5 times I. And there's your conjugate complex pair. Complex conjugate pair. Complex conjugate pair. And again, make sure that I is distinctly outside the radical or you'll lose points. What?
When are we going to go over our quiz?
Probably tomorrow, once more people have taken it today. There's still too many people that haven't taken it, and if I give the quizzes back, some of those people might try to get the answers from people that have it back in their possession. So I'm waiting on that. But the stuff that people missed on the quiz, a lot of it was contained right here in these review problems. So in terms of getting the skills reviewed, we just did that. I couldn't be Superman. I'd be playing with my abs all day. Thank goodness I'm not. All right. Comments or questions? All right. You have the rest of the class to work on your 5.3 homework, which is due tomorrow morning. Okay? Let's write that down. Yes. If you registered for College Board? Oh, I have no idea.